In this video, we will talk about what absolute and local max and min values are. So I want to motivate this with an example. So we have this graph of this function here. So definitely take a minute or so to pause the video and draw this graph. But now I want to introduce some definitions. Okay, so the preliminary part of this says I'm going to let C be a number that's in the domain D of f. So we're calling the domain of our function f D. Then f of c, so the output that I get when I plug c into the function, is so the first definition is what's called an absolute maximum value. f of c, this is the absolute maximum value of f. If f of c, if that output is greater than or equal to f of x for all values of x in, so this is the symbol for in, or is an element of, in D, in the domain. So this is saying that the output when I plug c into my function needs to be greater than or equal to every other output that I can have. All right, so there's a similar definition that I can give for an absolute minimum value. So f of c is the absolute minimum value of f if f of c is less than or equal to f of x for all x in D, for all x in the domain of the function. So this is saying that the output when I plug c into my function, that needs to be less than or equal to all of the other outputs that I can get. All right, so if I go to my graph, so the absolute max, kind of on a conceptual graphical level, is the highest point that I have, the biggest the y value ever gets. All right, so that absolute max is at -3, 5. This is the largest the output ever gets. It's 5. All right, so the absolute min occurs at this point, 5, -2. That's the smallest the output ever gets. So the absolute min is going to be here. So we also have terms that help us describe points like -2, 3, which isn't the lowest point on the graph, but it's lower than the points kind of in the immediate vicinity around it. Okay, and those are called local mins and local maxes. So f of c is the local maximum value of f if f of c is greater than or equal to f of x for, or let me say it like this, that's got to be the case on some open interval containing c. All right, and similarly, f of c is a local minimum value of f if f of c is less than or equal to f of x on some open interval containing c. On some open interval containing that number c. So let's label the local maxes and local mins in our picture here. All right, so let me first label local maxes in the graph. So we have a local max if the y value at a particular point is going to be greater than or equal to the y values kind of immediately next to it, to the left and to the right. So one of the places that happens is at the point 1, 4, because I could take an open interval around 1, maybe even if I just make it pretty small here, a little bit to the right and a little bit to the left around 1, some open interval. And on that open interval, the y value at the point where x is 1 is greater than or equal to all the y values kind of immediately to the right and immediately to the left of it on that small open interval. So that makes this a local max. There's another local max at the point -3, 5. Kind of even more conceptually, a local max kind of corresponds to the top of a hill in a picture. And that's happening at -3, 5 and at 1, 4. They're sort of the top of a hill. Okay, what about local mins? So local mins. Okay, so local mins need to be sort of low points in a graph, or valleys. So we have one local min at -2, 3. If I were to form an open interval around -2, if I make it just very small, very close to -2, the y value at this point is less than or equal to all the y values on that open interval. There's one other place where I have a local min. And this one might be a little bit trickier, but it's at 3, 1. 3, 1 doesn't exactly look like a valley or a low point. And it's a little bit weird because it's piecewise, but if I were to form an open interval around this x value, around x equals 3, and go a little bit to the right and a little bit to the left, we would be looking at this part of the graph, so a little bit to the right of this hole, a little bit to the left of that hole. And on that interval, the lowest y value is here when at the point 3, 1. And that makes that a local min. All right. So let me just write some of those values explicitly. So if I wanted to write the absolute max value, and the key word here is value, the word value means it's talking about the y value. What is the output? Even in the definition here, it's talking about f of c, the output when you plug c in. So the y value I ever got was 5. That's my absolute max value. Oh, let's put that in black. And if I wanted to specify the x value, I would word it like, and it occurs at x equals -3. All right, now let's do absolute min value. So the absolute min value, there's that keyword value indicating I'm talking about the y value, the output. The min value was -2. That was the smallest my y value ever got. And this occurs, and it occurs at the x coordinate 5. All right, I want to introduce a little bit more terminology here. So there's a word that I use to collectively refer to the absolute max and the absolute min values. These are called the absolute, I'll just abbreviate absolute extreme values. Okay, so the word extreme refers to both the max and the min. Okay, and for the local max and the local min, we call these the local extreme values, or sometimes they're called the relative. Relative is just a synonym for local. Relative extreme values. Okay, so one final important comment that I want to make about that picture and some terminology is that an endpoint of my interval or my domain, an endpoint cannot be a local min or max, since for the local max and local min value definitions, it talks about this open interval containing that number c. But if I'm talking about an endpoint, an open interval that contains c that contains that endpoint would extend past it. It would extend past that endpoint. And that would make us be outside the domain. So that's why in this picture, we didn't label these endpoints as local mins or local maxes. So the question I want to end this video by stating is the question we'll be interested in answering is how do we find the absolute and local extreme values, so that means maxes and mins, extreme values of f algebraically. So by algebraically, I mean without the graph, because if I have the graph, I can just look at it and identify where they are. So how am I going to do algebraically? So for absolute extreme values, we're going to talk about that in this section, in a future video of this section. For the local extreme values, we will look at that in section 4.3. All right, in terms of our goals for this section, we finished our first goal, identifying where absolute and local extrema is just another for extreme points, occur graphically.